Think back to the definition of limits that we had in the previous video. What could it mean for a limit not to exist at all? One way to say it is that no matter how close x is getting to c, f of x is still taking on values that are far apart, so the value of f isn't sort of settling down to any one thing. Let's see an example. Consider this piecewise function. If I look at the limit of it near 2, near that breaking point between the two formulas, then what happens? Well, if I put a delta strip around 2, no matter how narrow it is, it's still going to include a little bit of the function down here, where the value is close to 6, and a little bit of the function up here, where the value is close to 10. That means no matter where I put my limit, if I choose a small epsilon, like 0.1, then the epsilon strip's not going to be able to cover both the numbers that are near 10 and the numbers that are near 6. If I try to put it somewhere in between 10 and 6, like at 8, it might end up covering neither of those two extremes. Or say if I put it at one of the extremes, like at 10, which is the value of f at 2, then I'm still not covering those lower values down close to 6. So wherever I put the limit, if the epsilon is small enough, it's not going to be able to cover both the values near 10 and the values near 6. And that's going to happen whenever f keeps on taking two different values, two values that are far apart, no matter how close we get. Here's another limit that does not exist. Cosine of pi over x as x goes to 0. Why not? Well, let's start by seeing what the graph of this function looks like. Since this function is cosine of something, we know its values are going to fluctuate between plus and minus 1. So let's think, when is cosine of pi over x equal to 1? Cosine is 1 when its argument, which here is pi over x, is an even multiple of pi. So at 0, 2 pi, 4 pi. That means x is 1 over an even number. So when x is 1/2, 1/4, -1/2, -1/4, and so on. When is it -1? That would be when x is 1 over an odd number. So at 1, 1/3, -1, -1/3, etc. So near 0, the graph is going to fluctuate a lot. It's going to keep on switching between 1 when x is 1 over an even number and -1 when x is 1 over an odd number. So we're going to have the same trouble as before. Whatever candidate limit L you choose, wherever you try to put your epsilon strip, maybe you'll get those 1s but not the negative ones. Maybe you'll get the negative ones but not the 1s. As soon as epsilon is smaller than 1/2, you're not going to be able to get both of them. The textbook considers this related. You should look at what's written there to make sure you understood this argument. In the next video set, we're going to talk about limits in more detail, and we're going to have our first tools for calculating limits precisely.